Alright, let's start 12.4b with a review of what we learned in 12.4a. So on number 1, we want to find the area of this triangle. You learned in geometry that area is for a triangle is 1/2 base times height. But if you don't know the height, you could also use the formula 1/2. Then multiply any two sides together, and then the sine of the angle between those two sides. So in between the 8 and the 7, we see a 35-degree angle. Alright, using a calculator, you get 16.06, rounded to the nearest tenth is 16.1, and then whatever the units are, squared. Okay, for number 2, we need to solve that triangle. So solving a triangle means finding every missing angle and missing side length. We know that the angles have to add up to 180. So 100 plus 30 is 130. So the last angle has to be 50 degrees to make the total 180. Alright, so now we're going to use the law of sines to find the other two side lengths. So what's the only combination we know both of? Well, we know this side length is 10. That is C because it's across from angle C. So we're going to use sine of C, which is 30 degrees, over the length of C. Now we could use that to find side A and side B. Alright, let's find side A first. So sine of angle A is 50 degrees. And we don't know the length. And remember, sides use lowercase letters and angles use capital letters. So I cross multiply A sine 30 equals 10 sine 50 and divide by sine of 30. That gives us A equals 15.3. So we have one answer here, one answer here, and now we have to find side B. Alright, so I'm going to use the first half of that equation again, sine 30 over 10 equals, now we want to use sine angle B over side length B. Alright, so cross multiply, you get B sine 30 equals 10 sine 100. So now divide by sine 30. Alright, and I'll write the answer up here. B equals 19.7. Okay, so now let's get into some new stuff. Alright, first sentence. If you are given two sides and the angle in between, which is side angle side, SAS, there's going to be one solution. Alright, now if you're given two sides, but the angle they give you is not in between those two sides, there are three possibilities. There could be no solution, one solution, or two solutions. And we're going to teach you how to figure out which one it is. Alright, if you ever get sine of an angle that's equal to a number bigger than 1, you're going to have no solution. So if you're cross multiplying and you end up with sine theta and it's a number bigger than 1, that's impossible. The reason it's impossible, sine is opposite. Sine equals opposite over hypotenuse. And if this were bigger than 1, that would mean opposite is bigger than hypotenuse, which is impossible. Alright, if your sine theta is smaller than 1, which that's what it's supposed to be, you will either have 1 or 2 solutions. And a good way to check your work, make sure the longest side is always across from the largest angle, and the shortest side is always across from the smallest angle. Alright, so on the back we're going to practice all 3 of these possibilities. But before we do that, let me explain how can a triangle have 2 solutions. So I'm going to draw an example and I'll just make up numbers. So let's just say that's 5. And then I'm going to draw another side here, but I'm going to make it dotted because that'll be the side that we don't know the length of. And this angle that we made, what would be reasonable? Let's just say that's 40 degrees. Alright, so right now we're given an angle. Let's just call that angle A, 40 degrees. We're given a side. We know it is 5, and I'm just going to call this side B. And let's make up one more number for, this will be for side A, because it's opposite of the angle. So let's say side A is 4. Okay, so the reason there's 2 possible triangles here, I can draw that third side like this as 4, or, and notice both of these sides look like they're the same length. So you could have, so with this information here, you could have this as the triangle, or with the same exact information, you could have this as the triangle. Both of those triangles have a 40-degree angle, a side of 5, and a side of 4. So that's why there's 2 possible solutions sometimes. Okay, so again, if you're given side angle side, there's 1 solution. But in this case, we're not given side angle side because these 2 sides, the angle in between would be a different letter. That's the rule. If you have a side labeled R and a side labeled S, the angle in between has to have a different letter. So in this case, angle T would be in between. So this is not SAS, this is SSA, because we have an angle, but it's not in between. So we're going to use the law of sines. What's the only letter that we have both the angle and the side? That would be the letter R. So it's sine of a 95-degree angle, this is R, over little r, which is the side length. Alright, we have no choice. We're going to use angle S because we only know side length S. We don't know angle T, and we don't know side T. Alright, cross multiply, you get 12 times sine 95. So again, I'm multiplying diagonally. I'm multiplying these together. Then I'm going to multiply these together next, equals 10 sine of angle S. And angles always use capital letters. Divide both sides by 10. And you end up with, so these 10s will cancel, you end up with 1.195 equals sine of s. So again, as soon as you see sine of an angle being bigger than 1, that should tell you no solution. Let's say you didn't catch that. So if you didn't catch that, the next thing you would do is you would take the inverse sine of both sides. So if you take the inverse sine of this, it cancels out the sine. And then you take the inverse sine of 1.195. If you do that, your calculator will give you an error. So no solution. So again, there's two reasons you should be able to tell it's no solution. One is sine of an angle cannot be bigger than 1. And then the second way is if you do it on the calculator, you get an error. Okay. Alright, so again, on number 4, we have SSA. We know it's not side angle side because the angle in between N and P would be a different letter. It would be M. Alright, so we're going to start with the law of sines. Sine of, and what letter do we have both of? We have both angle N and side N. Sine of N, capital N, is 32 degrees over, and then side N is 7. And now we have to use P because we don't know anything about either of the M's. So this is going to be sine of capital P, which is angle P, over the length of side P. Cross multiply. 4 sine 32 equals 7 sine P. We're trying to get the variable by itself, so first we have to make the 7 go to the other side. Alright, so doing this, we get sine P on the right equals, using a calculator, we get 0.3028. So now you want to do the inverse sine of both sides. So that looks like sine to the negative 1 power. On your calculator, you're going to push second sine. And then if I do that to the right side, the inverse sine and the sine will just cancel each other out. On the calculator, we get that P equals, and the directions say round angles to the nearest degree, so 17.6 becomes 18 degrees. Okay, now before I box this answer, I still have not determined, is there going to be one solution or is there going to be a second solution? So here's how you find the second solution. The second possible answer is the supplement of the angle you just found. So we just found 18 degrees. Remember that supplementary angles add up to 180. So what's the supplement of 18 degrees? 180 minus 18 is 162 degrees. Alright, so this is our second possible answer. But can a triangle have a 32 degree angle and a 162 degree angle? The answer is no, because those already add up to more than 180. So in this case, the second answer is not possible. So there's only going to be one solution. Okay, so the first part of the directions was actually state whether it has no solution, one solution, or two solutions. So let's do the first part and say there is one solution. And we could start boxing our answers. So there's our first answer. And now, once you have two angles, you can easily find the third angle. So right now we have 32 degrees, we have 18 degrees, so those add up to 50 degrees. Remember, all three angles have to add up to 180. So what angle do we not have yet? We don't have angle M. So if we take 180, subtract the 32, and subtract the 18, that gives us that angle M is 130 degrees. So there's our second answer. And another reason that this 162 wouldn't work, notice side P is the shortest side. The shortest side cannot have a really big angle across from it. The shortest side has to have the smallest angle across from it. Okay, so what have we not found yet? We have all three angles. We have side N, side P, but we don't have side M. So using the law of sines, let's find side M now. So let's use the same fraction as before. Sine 32 over 7 equals, now we're going to use the m's. So sine of 130 over, and we don't know lowercase m yet, cross multiply. M times sine 32 equals 7 times sine 130. Now we divide both sides by sine of 32 degrees. That gives us that m equals 10.1 and whatever the unit of length is. Alright, we're done with number 4. So this is another side-side angle problem. We're given side A, side B, and not the angle in between. The angle in between A and B would be angle C. Alright, so let's start with the law of sines. We know angle A, and we know side A, and let's use that to find angle B. Sine of angle B over, that's an 18 it looks like. Cross multiply 18 times sine 47 equals 15 times sine of B. Divide by 15. This gives you 0.8776 equals sine of angle B. Alright, so it's good that the sine of angle B is smaller than 1, so we know we're going to have at least one solution. Let's do the inverse sine of both sides. So inverse sine on the right will just cancel out the sine that's already there. Okay, so if you take the inverse sine of that decimal, you get that angle B equals, and side or angles go to the nearest degree, 61 degrees. Okay, so remember, there might be two solutions. So the way you find the other solution is the supplement of the angle that you found using trig. So whenever you do inverse trig, there might be another answer. So 61 degrees or, and what's 180 minus 61? That would be 119 degrees. Alright, now could this make sense? Well, we don't know yet what the longest side is. Is the longest side B, or is it the C that we haven't found yet? All we know right now is that B is longer than A. So angle B has to be bigger than angle A. And right now, both of these work. So I'm going to box both of these. Both of those are bigger than 47 degrees. Alright, so now let's find the third angle, angle C. So angle C, remember, all three angles have to add up to 180. So first, let's do this set. So 47 plus 61, and now subtract that from 180. So 47 plus 61 is 108. 180 minus 108 is 72 degrees. So angle C could be 72 degrees. And now we have to do this again, but pretending that angle B is 119. So let's do it with 47 and 119. 47 plus 119 is 166. So what does the third angle have to be if those add up to 166? The third angle has to be 14 degrees. Alright, so an important thing to notice. For angle B, the two answers are supplements of each other. But for angle C, the two answers are not supplements of each other. So you only use supplementary angles for the one you did trig on, the one you used sine for. We did not use sine to find angle C. So you only find supplementary angles for the one that you used trig. Trig is SOHCAHTOA, sine, cosine, or tangent. These definitely do not add up to 180. Okay, the last thing we have to find is side C. So let's use the same first fraction. Alright, now we're going to have to find two possible answers. First, pretending that angle C is 72 degrees. Cross multiply C sine 47 equals 15 sine 72 This gives you that C equals 19.5. And now you could set up another cross multiply, another ratio, but I'm just going to take a shortcut, and I know that I'm going to do the same exact process, except this 72 here is going to be 14 degrees instead. So do the same exact calculation, but change that 72 to a 14. Okay, so on my calculator, I type 15 sine 14 divided by sine 47, and this gives me that C equals 4.96 rounds to 5.0. Alright, and I'm going to write it side by side. So 19.5 or 5.0. Alright, let's check our answers. So here's a way you could check. Let's check our first set of angles. The first set of angles, we had 47 degrees, 61 degrees, 72 degrees. Alright, as you can see, angle A is the smallest and angle C is the biggest. So if angle A is the smallest, then side A should be the shortest, and side C should be the longest. So our first set of answers are correct. Now let's check our second set of answers. So for our second set of answers, we still have 47 degrees. We have 119 and we have 14. So in this case, angle C is the shortest and angle B is the longest. So if angle C is the shortest, angle C is the smallest, side C has to be the shortest, which it is. Alright, and in this case, angle B was the largest, so side B should be the longest. Alright, so those match up. So you always want to make sure that the biggest angle is across from the longest side, and the smallest angle is across from the shortest side. And then the last thing we didn't do is we didn't say how many solutions there are. So in this case, there were 2 solutions. Alright, so to quickly summarize, if you ever get sine of an angle and it's equal to a number bigger than 1, there's going to be no solution. Now if you get sine of the angle and it's smaller than 1, then there's either going to be 1 or 2 solutions. So after you find the first angle using inverse trig, the other possible angle is the supplement of that angle. However, going back to number 4, when we found the supplement of that angle, it was impossible because if you have a 162, you can't have a 32 because that adds up to more than 180. Going back to number 5, this was possible because 119 and 47, those add up to a number less than 180. Okay, that was kind of a lot for one lesson. Make sure you practice with your homework and you're checking your answers. I'll have office hours this week if you have any questions.